If you're eating whole foods, avoiding junk, and staying within reasonable calories, but fat loss isn't happening, the issue is rarely effort. It's usually metabolic signaling. Fat storage is not determined by whether a food is labeled healthy. It's determined by hormonal environment, energy flux, and nutrient timing. Today we're going to examine the biological mechanisms that keep the body in fat storage mode, even when you're eating clean. Adipose tissue, also known as fat tissue, is not passive. It constantly reacts to hormones that tell it when to store energy and when to release it. The key regulator of fat storage is insulin. Insulin has two primary roles: move glucose into cells and inhibit lipolysis, which is fat breakdown. When insulin is elevated, fat breakdown decreases. This does not require overeating. It only requires frequent or prolonged insulin signaling. Now here's what's important. Insulin elevation is not determined solely by sugar intake. It's influenced by meal composition, frequency in eating, stress hormones, sleep quality, and metabolic sensitivity. If insulin remains elevated for extended periods, fat release becomes physiologically restricted. Even in a mild calorie deficit, this can slow visible fat loss. Some foods marketed as healthy can still spike insulin significantly. Some of these foods include smoothies loaded with fruits, oatmeal without protein, granola, low-fat yogurt with added sugars, fruit juices, dates or dried fruits when snacked on frequently. These foods are nutrient-dense, but when consumed alone, they can create rapid glucose increase which triggers insulin. And repeated insulin spike suppresses lipolysis, which is fat burning. This does not automatically cause fat gain, but if the pattern is chronic and paired with low activity or poor sleep, the body remains in energy storage bias, causing it to hold on to fat. The issue is not that these foods are unhealthy. The issue is metabolic response. Each time you eat, insulin rises. If meals are spaced appropriately, insulin returns toward baseline between feedings. But with constant snacking, even on small portions of healthy foods, insulin exposure becomes cumulative. This matters because fat breakdown primarily increases when insulin declines. If insulin rarely falls, the metabolic environment favors fat storage over mobilization. This is a eating frequency issue, not a calorie issue. Many people try to fix fat gain by cutting calories, but aggressive calorie restriction can increase cortisol, a stress hormone, and cortisol raises blood sugar, which increases insulin. So now you have low calories, high stress, and elevated insulin. Your body interprets this as instability, and it becomes protective. When the body feels threatened, it conserves energy, and fat storage becomes a safety mechanism. This is why some people eat very little but still struggle to lose weight. Another overlooked factor in weight gain and difficulty losing weight is insulin sensitivity. When tissues become less responsive to insulin, the pancreas compensates by producing more. Higher circulating insulin increases fat storage signaling even if glucose levels appear normal. Early insulin resistance often presents subtly as increased abdominal fat, post-meal fatigue, sugar cravings, and difficulty losing weight despite dietary improvements. In this context, eating healthy is not enough. Improving insulin sensitivity becomes central. Fat storage mode is not a switch. It's a state characterized by frequent insulin exposure, reduced lipolysis, elevated cortisol, metabolic adaptation, and impaired fuel flexibility. Fuel flexibility refers to the body's ability to shift between glucose and fat breakdown efficiently. When flexibility declines, reliance on glucose increases. This amplifies hunger and reduces access to stored fat. The body system becomes biased toward fat storage. Rather than focusing exclusively on calorie reduction, consider metabolic structure. First, build meals around adequate protein and fiber to blunt rapid glucose spikes. Second, reduce constant snacking to allow insulin to return toward baseline. Third, prioritize sleep to improve insulin sensitivity. Fourth, manage chronic stress to prevent cortisol-driven glucose elevation. Lastly, incorporate resistance training to improve glucose disposal independent of insulin. These shifts do not fight the body. They restore regulatory balance. Fat loss becomes more accessible when signaling normalizes. If fat loss has felt inconsistent despite disciplined eating, the issue may not be effort or food type. It may be timing, hormonal signaling, and metabolic context. Understanding fat storage physiology changes how you approach nutrition. In the next video, we'll discuss why stress causes belly fat. Want to understand your mind and body better? Subscribe to Neurokind and turn on notifications so you never miss insights that help you think better, feel better, and live healthier.